This is the video for Friday. On line 13, you need to write relations and functions. So line 13, table of contents, is relations and functions. Then we will turn to page 13. And title this page Relations and Functions. So we're going to start off with some definitions. The first definition is a relation. And a relation is a set of ordered pairs. So basically, you're just working with a set of ordered pairs. And the key part is that they're surrounded by brackets, which are these squiggly things. A relation can also be written as a table, a graph, or a mapping diagram. And we'll explain each of those. So a relation is a set of ordered pairs. When it's an ordered pair, it's surrounded by these brackets, the squiggly lines. And it's written as a table, a graph, or a mapping diagram. So here is an example. I start with my bracket. So I have 1, 5, 2, 3, 3, 2, and 4, 2. So that would be a relation because it's a group of ordered pairs surrounded by brackets. All of these belong together in the same graph. A table of the same data would have 1, 5, 2, 3, 3, 2, and 4, 2. You're just taking that relation and you're putting it into a table, the x value and the y value. A graph of this relation (1, 5) over 1 up 5, 2, 3 over 2 up 3, 3, 2 over 3 up 2, and 4, 2 over 4 and up 2. From yesterday, what we learned, this picture right here is what's called a discrete graph, right? It's made up of dots, discrete and dots. And the third type is a mapping diagram. And a mapping diagram is kind of like an input-output table. So we'd have 1 and it's partnered with 5. 2 and it's partnered with 3. 3 and it's partnered with 2. And 4. But I already have 2 written down, so I can draw an arrow up to 2. Continuing on with our vocabulary, we need to talk about domains. In a relation, there is a domain, and the domain is the x-coordinate. It's just the x-coordinate. So the x value, what we call the x-coordinate, is also known as a domain when you're speaking about functions. The range is the y-coordinate in a relation. So again, these vocabulary terms of domain and range are used only when we're talking about functions. So if I'm using this data set up here, the domain is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The range of this data set, which is the y-coordinate, is 5, 3, 2, 2. 5, 3, 2, 2. 5, 3, 2, 2. 5, 3, 2, 2. You can write it out of order, or you can write it in order, or you could take it and say that 2 repeats, so you only list it once. All 3 of those are acceptable answers for range. So again, in a relation, we can have an ordered pair set, we can have a table, we can have a graph, or we can have a mapping diagram. All of those are relations, meaning that they're just ordered pairs. They're numbers that belong together that describe a situation. Inside the relation, there's a domain, which is the x value, or the x-coordinate, and the range, which is the y-coordinate. You can list them out. If you want, you can put them in order, least to greatest, and you can take out duplicate data. So why do we want this? Well, we use this knowledge, we use this idea of domain and range to decide if something is a function. So today you're going to be asked, is this a function? And a function is a relation if the domains, the x values, are all different. That just means no x values repeat. We don't really care about the ranges. We only care about the domain, the x value. The y value, that can repeat and it's fine and it's not a big deal. But if the domains repeat, no, it is not a function. If all of the domains are different, yes, it is a function. So let's do some practice. If I gave you the relation 3, -2, 5, -1, 4, 0, and 3, 1, can you find the domains? Can you find the range? And is it a function? All right, let's list the domains. 3, 5, 4, 3. The ranges, -2, -1, 0, and 1. And is this a function? A relation if the domains are all different. So I look at the domains. Are they all different? No. 3 repeats. What if I gave you a mapping diagram? -4, -8, 4, and 5. and 4 goes with 2, negative 8 goes with 2, 4 goes with 1, 5 goes with 1. So the domain, the range, and is it a function? The domains are negative 4, negative 8, 4, 5. And the ranges are 2, another 2, 1, and another 1. Is this a function? Well, are all different? Are the domains all different? Yes. The domains are all different. So tonight on your homework, you're going to be changing relations, taking a relation and changing it to a different form. So maybe you have a graph and you have to make the ordered pair, or you have a table and you need to make the graph, or a mapping diagram and you need to make a table. You'll also be asked to find the domain and range of different types of relations. And then lastly, you'll be asked, is it a function? So looking at different types of relations, is it a function? Yes, if all of the domains are different. No, if the domain repeats.